Actually, this is really exciting because it's amazing how many companies now are involved with exoskeletons. It's gone a very, very long way. And I think many companies now have a lot of different departments that are um, uh, concentrating on exoskeletons. And what I'd love for the panel to do is introduce themselves, tell us which department you represent at your company, and tell us your number one reason why you think exoskeletons are important in your field. Can we start with you, Sudhakar, please?
Check. My name is Sudhakar Rajulu. I work at NASA, and I'm a technical manager for anthropometry and biomechanics facility at Johnson Space Center. And my interest in exoskeleton, actually, I don't want to surprise you all. I don't work on exoskeleton, but I do work on spacesuit. And spacesuit is very much a full ensemble exoskeleton. And our primary interest in the spacesuit is to make sure how it can accommodate and fit wide range of population, both male and females, and then also spacesuit. I don't know if you all know some other things about the spacesuit. It's very cumbersome to use, and it limits the performance and how to maximize the performance. So our lab is engaged in working with engineers and designing the spacesuit, how to make it more adaptable and functionally comfortable for the crew members.
Thank you.
Hi, my name is Marty Smets, and I'm a technical expert representing the advanced manufacturing team at Ford Motor Company. So our interest in exoskeletons, we like to bin everything into the now, near, and far at Ford. And so for the now, we're focusing on passive shoulder systems to tackle shoulder problems. So as you heard in the last panel or the last presentation, shoulders are the new back, and they cost us more per injury on average than backs, despite the fact that the long-term injuries on backs, they're very, very, very expensive. So our initial deployment is around tackling specifically shoulders. We'll get into more about why we're going after shoulders during the discussion. In the near, I see quasi-active exoskeletons providing feedback on what operators are doing. We monitor our parts to quality check them as they go down the line, and as they start trending out of spec, we make a change before we have a problem. And we just don't do that with humans yet, mostly because of sensorization and the lack thereof right now, or historically. So in the near, I see an opportunity to monitor operators and make changes to their applications and their jobs and their operations before an injury happens. I think that would be a very fantastic goal, and we've been looking at that for quite a while. And in the far was that we focus on the factory of tomorrow, which is my organization's deliverable, and we see how manufacturing and consider how we approach it. It's very modular, and I see the need to have strength augmentation on a person that's mobile, because we're not going to have the overhead steel to hang hoists to accommodate flexible assembly. So that's our interest in exos.
Hi, my name is Vinzent Rudtsch. I'm working for Audi Logistics Innovation Management, and the responsibility for me within my department is basically to evaluate new technologies, not only exoskeletons, but also VR, AR, everything that can support and improve our logistics processes, and to be more precise, our in-house logistics processes. So our main interest in exoskeletons comes basically from a lot of heavy lifting within our logistics processes. Obviously, we have a high rotation of our car assembly, and the logistics processes have to cope with that. So we have a lot of people bending over a lot, and that's why we were testing some devices mainly for back support. So from our perspective and from my perspective, I'm more focused on these back supporting devices, and we've done some testing with that, and not so much. And therefore, I think we have more similarities from our point of view with these, with the UPS or other logistics providers, and not so much with the assembly. That is a different department of mine. So I'd like to bring more of these aspects into the discussion.
Hey, hello. All right, there we go. It's really bright in this room. I want to see everyone's faces, but it's like being the Rolling Stones or something, only we're talking about exoskeletons. Very weird. I'm Josh Shabtai. I'm Director of Ecosystem at Lowe's Innovation Labs. I'm probably the outlier here at this conference in that our focus as Lowe's Innovation Labs is probably more rooted in how we serve our customers. And so raise your hand if you've been at a Lowe's anytime in the last like month. All right, good. Thank you. Drive our share price, please. Right, we serve all of you guys. We serve a healthy pro segment, contractors, electricians, plumbers, roofers, masonry. Not only do we sell them things, but we provide services that help keep them safe now and into the future. We also act as a support network for the company's most important asset, our store associates who serve our customers every day, right? And so our interest in exoskeletons, in on-the-floor robotics, in mixed reality, virtual reality, a lot of that does help our store associates serve our customers better. Exoskeletons have been a really interesting place for us to spend time in that it helps both our associates in the stores and distribution centers, and might have implications for how we continue to serve the pro into the future. So thanks for having me here.
Hello, my name is Giovanni, yes, Pacini. I'm based in Italy, even if I'm representing a Swedish company with a Swedish name, which is not telling anything generally in the US. Because our brand is mainly well known in the rest of the world. In the US, we are having Frigidaire brand, and maybe also other ones like AEG brand. This is the German high-end appliances we are selling and producing. Well, I'm leading globally digital industrial operations, so I'm director of this team, and inside our digital activities, we have a lot of, let me say, introduction technologies in our factories, and we share an hashtag inside our team, which is our motto, which is digital is all about people. That means that all the digital transformation has the purpose of improving the life of the people. We can think to what has been the change in our personal life due to the interaction of smartphones, for instance, and consequently also how digital technologies can enhance a better way of working for our company. And since the purpose of Electrolux is shape living for the better, well, we are trying to shape living for the better, selling 60 million of appliances all over the world to have a better experience in our home. But for myself and my department, which is inside industrial operation, the main focus is having a better living experience for our 30,000 workers, mainly in the factories or the supply chain. That's why, obviously, wearable devices, exoskeletons, are a core component in making our job life and working life better, more sustainable, easier, and getting so also better quality out of our activities and better health of our employees.
Very good. Thank you. I think that what I'd like to start with is exoskeletons come in two categories, passive or powered. So what I'm seeing in the market for the most part is passive exoskeletons being the ones that are more practical because there's no battery, there's no tethering. But there is some work that's being done with powered exoskeletons. And I'd love, Giovanni, if you can share your experience with the BioServo.
Yeah, sure. We are both working with both the categories. On powered exoskeletons, we've been testing Iron Hand, which is iron glove that is having powered grip, let me say, on the hands. This is because for us, the main illnesses and injuries we are having is on the hand and wrist. And so we were trying, everything is related to this particular area of the body is of great interest for ourselves. Unfortunately, sincerely, the kind of activity that we are requiring is not so compatible with Iron Hand. And we are searching for something which is leaner and maybe also quicker in the response of the hands.
Very good. So on the passive side of exoskeletons, a lot of companies are looking at it for all kinds of reasons, of course. There's the productivity angle, but I think a healthier worker is one of the main motivations for exoskeletons, and having a better and healthier retired life. And the way to validate exoskeletons And that the fact that they do that they do provide for a healthier worker, is by becoming an expert, which our company had to become an expert in ergonomics. It really is a major component of this. And I would love, Marty, for you to tell us about how ergonomics is a key technical component in your evaluation of exoskeletons, their functionality, and how you can justify the investment in time and energy you put into exoskeletons.
Yeah, sure, Joseph. So, our journey with exoskeletons actually started back in around 2011 with some of our friends in aviation. My colleague, Dr. Chris Reed from Boeing is over there, and one of his predecessors, John Amell, we partnered with Ford and a vendor to make a hip-mounted solution on an off-the-shelf Steadicam vest to support power tools. And it may work well in an environment like aviation, where you may have 15,000 similar tasks to perform all day, maybe putting rivets in a wing, and that works well for them. But we didn't start with our end user, which was our assembler and our operator in the assembly plant, and they do other things. And so we made some design decisions that just wasn't successful. So we started from the beginning with our operators, partnered with our UAW, National Joint Committee for Health and Safety, and charted around a specific cause. And the first-gen devices were mostly targeting shoulder. And if we look back in our medical history, and we have a great analytics dashboard around, so big data around health and safety was one of the first thing we tackled with big data. So we can pull up in a browser, and I can look at all the shoulder injuries across all our North American plants. And over the 2 years preceding our rollout, we had 23 operators off work every single day for a 2-year period, only because of shoulder injuries. So the previous talk was saying claims are $25,000 to $35,000. A shoulder injury can cost us anywhere between $40,000 and $100,000, depending on how long that person's off work. So we have a high problem with shoulder injuries. It's very, very costly, and it was very prevalent in our assembly plants. So those are good grounds to start down that pathway. The other problem is, at Ford, we do a lot of upfront planning for job design. We have a very integrated ergonomic process. We call it our digital pre-assembly process, where we look at every new part and every new process digitally, using digital human models. And back in the day, before force-based posture prediction existed, we were using optical motion capture systems to mark up operators, have them perform future jobs, capture their kinematics, predict capability. So we spent a lot of time trying to design safe work. So raise your hand if you have a background in biomechanics, formal educational training in biomechanics or ergonomics. So there's not a lot in the room, and this is mostly an enterprise wearables conference, so that's interesting to see. So one person raised their hand. So if I asked you to hold your hand up in that posture for the duration of this panel, you probably wouldn't be able to do it. We trade off endurance and strength at the shoulder for range of motion, which has made us very successful over the years of evolution, picking fruit and becoming these successful creatures. But we trade off, we're very weak and very prone to fatigue-related problems. Yet we still analyze the shoulder risk using this percent MVC method, where you're comparing the strength of the task to the maximum strength of the person. So if we design a job, we look at the torque at every joint, and the joint that is the limiting joint, so the weakest in that particular posture and force exertion, that's what limits the task. And the majority of the time, it's the shoulder. But the approach to strength, like this percent MVC approach to the shoulder, isn't really correlated to poor health effects. We did a great project with a Canada Research Chair in Shoulder Biomechanics at the University of Waterloo, and we used a different model for predicting risk at the shoulder. So we took a bunch of jobs and said, this is the way we would classically analyze it, and let's take a different approach where we can take geometry of your kinematics of your shoulders, the posture of your shoulder, plus the force and loading conditions. We can predict the muscle activity of all the different muscles that actuate the shoulder. And they call it the shoulder complex because it's a very, very complex joint, and there's a lot of different muscles and tendons that cross it. So reeling this in, the biomechanical modeling of the shoulder is still very poor. What we found through that study is that we would have predicted risk differently if we had taken what we now know is a better approach to predicting risk at the shoulder. So now we have a threefold effect, okay? It's very costly for us, it's very prevalent for us, and our prediction methods for shoulders aren't that great. So we deployed passive exos, and now we're 12 months into a longitudinal study with Virginia Tech to measure the uptake. So we survey at milestones to get qualitative feedback on the operators. So that was our justification, Joseph, as to why we rolled them out. We had, I think, as you've heard over the course of the conference, to launch technology, you need to start small, you need to tackle a real problem, and then you can scale from there. We were told to deploy them globally, And you struggle in distal regions because of managing these devices, storaging devices, time zone problems, but you have an opportunity to generally raise the level of understanding about what the tools can do and can't do. So we'll get more into that.
Excellent. I think everyone here is always going to have this question on their mind that they have to justify to management, the ROI. What is the return on investment on exoskeletons? And I would love for you, Vinzent, because we know that everybody on this panel here has that challenge with management. Can you please share your experiences on how you are trying to develop an ROI model?
Yeah, sure. I mean, basically, you can use these exos for two different reasons. You can directly hit on a process where you say you improve the efficiency of the worker or the person who is wearing this exoskeleton by X%, and that'll make it pretty easy for you to calculate some kind of ROI for this process and for this device that the worker has to wear. On the other hand, and we've talked about that more frequently actually, is that you expect some long-term output, workers being more healthy, less absenteeism of the worker. But this is an effect that you will notice only after years, basically. And so I really appreciated the discussion and the presentation before the break, where we were talking exactly about this issue. And this is something that in a company I find extremely hard to implement, because when I say I want to order I don't know, 300 devices for this area and these people to use these devices, this will cost me a certain amount. And then everyone will ask me, okay, what's really the effect behind it? And to be honest, I really can't answer that question with figures and numbers behind it, because I really can't say by how many % is this risk reduced that the people will have some permanent damage in a few years. And then if they have a permanent damage, what does it mean to me? It doesn't necessarily mean they can't do anything anymore. They will have some limited capability. They won't be able to work in every process or the process they have been working before. So these are effects that everyone has a very good gut feeling about, but pretty hard to put that into numbers and to say, okay, for this kind of process, it'll be worth it to use exos, and for other processes, it might be too much.
Great. Yeah, I think that, the ROI is not easy right out of the gate because the technology is new, and you got to have a whole lot of exoskeletons in a factory over a long period of time. So I think with time and sooner rather than later, we hope to see good ROI measures to make it easier to get those budgets approved. I'd love to switch to the topic of the workforce. Can I get a raise of hands on people here that are aware that the world is having an aging workforce population and how big of a challenge that is? That's a lot more than I thought, so maybe I'm not going to educate you a lot on that. But Japan is going to have, by 2050, Japan is going to have 70% of its workforce over 65 years old. The average worker, the average welder in the United States, their average age is 57 years old. Articles are constantly coming out. I just read one in the Wall Street Journal. I actually shared it with the panel over email of the aging workforce, and it's even a bigger challenge in Europe than the United States, Germany and Italy especially. And I know, Giovanni, you are well aware of this and it concerns you, and I'd love to get your perspective on the aging workforce and absenteeism and how you think exoskeletons are essential to address part of this challenge.
Well, yes, this topic is top of our mind, obviously. We have 5 production units in Italy and 1 in Germany. And our population is becoming more and more aged. This is leading for us to do main consequences. One is the absenteeism rate is very high. That for us can be also above 10%, and that is creating a lot of problems, obviously, in the normal production. The second point is that we have also a lot of people with reduced working capabilities. So we need to reshape production lines and activities in order to cope with this limitation of the workers. So that is the result of probably 30 years working on the assembly lines as they were designed in the past. Now we are able to redesign completely our production lines, simulating every single workplace and evaluating ergonomics during the design of the product and assembly lines, which is giving to us a very big advantage in start having much better working condition for everyone from the beginning, and obviously having job rotation in order to, let me say, avoid to have peak of ergonomic effort and load just on some professionals. At the end, when we are not able to also to avoid at all some ergonomical positions that are not favorable. We are also introducing exoskeletons, helping people in order to feel less stress and having a better working condition. That's why we're working almost on upper limb, back, shoulders, as mentioned, and then lower part of the body for legs. So almost all the different areas of the body for us are interesting because we have long-standing position and repetitive activity every 20-25 seconds, cycle time.
Very good. So one of the essential things about exoskeletons is fit and function. People come in all kinds of shapes and sizes, so it's not easy to fit a 5'2" individual and then a 6'2" individual. Female versus male. Those are serious challenges for exoskeletons, and you have to have all the different sizes and different materials that are comfortable. And I did not realize that astronauts have a huge challenge with these spacesuits. And one of the big things that I learned from you is that, you know, whether it's male or female is a big deal. The load on the body. Can you tell us how challenging it is and what are the obstacles in having an astronaut be comfortable with a suit that weighs, how much was it, 250 pounds? So can you tell us please a little bit about how you work on that?
First of all, I think that, you know, prior to coming to NASA, I was doing my work on occupational ergonomics and concerned about industrial workers and their welfare and health in work settings. And so I'm very glad to see, you know, all the new tools and techniques being deployed to alleviate back injuries and shoulder injuries and everything. At NASA, you know, our primary goal is to, same as an industrial setting, not to limit any particular person from becoming an astronaut. So NASA has an inclusive policy of in bringing in females as well as male astronauts. The primary goal of the spacesuit, you know, is to protect the crew members from hazardous environment like lack of pressure, exposure to you know, not having oxygen, and also life support system. But then when we started using the spacesuit for performance, like working on a satellite and things like that, issues begin to crop up because there are differences between male and females in terms of their ability to exert, use a shoulder, or perform a task. And spacesuits do require additional forces and effort to manipulate. And you have to take into consideration, you know, how does a spacesuit or an exoskeleton in this case would work for a female population compared to a male population. So the adaptability for the gender is something that we take it very seriously because we cannot expect females to have the same amount of strength to manipulate the suit. And the same thing that applies to the exoskeleton also. The other thing is that we were talking about multiple suit sizes for the population. Even if you have enough sizes, adjustability for individual is going to be a challenge, and that's what we found at NASA also, is that with limited suit sizes available, how do you ensure, that a person who gets in will have a better fit, and that is still a challenge because even if you have enough sizes, it's very different than a customized exoskeleton or spacesuit. And one of the things that we grapple with is that NASA cannot have customized sizes for the astronauts, but with whatever the suits that we have, it should be able to not limit the performance or the comfort of the crew members. And we talked about shoulder injuries, and shoulder injuries are also a persistent problem among astronauts. So our goal is that to focus more on how do you make the suit to fit the person properly and understand the limitations of it so that we don't expose the person to more injuries. Like if you bring an exoskeleton into workplaces, yes, it does help you to alleviate some loads, and maybe it reduces the back pain and so on and so forth. But you may be introducing some of the problem while you're using, an exoskeleton.
Very good. I think that if you want an exoskeleton to be successful in space, there's many challenges with the oxygen, with protection from outside forces. But in a factory, I think that it just needs to be very comfortable, very easy to put on and take off. It needs to be just like safety glasses. You know what it does, you know the purpose of it and what it protects. You just put the exoskeleton, go on with your day. It needs to become streamlined, and it will not be streamlined unless it's comfortable. And I think that you guys is a great example of how you really have to work hard to understand the difference between the body sizes between men and women. So one thing that I would love to talk about and hear from Josh is, 2 years ago, you guys kind of surprised the world with Lowe saying, hey, we've got an exoskeleton. And it got a lot of press, and that's a great thing. But your perspective that you shared with me that I'd love for you to share with the audience is that you're almost not just doing it for your employees who are, moving material around the stores, but you're thinking of your customers also. So can you tell us, please, why exoskeletons are so important to you and to your field and to contractors, et cetera?
Yeah, sure. And this might be sort of a cop-out answer for a second, but you were talking about the aging workforce, a minute ago. We're experiencing that. It's a tight labor market here in the U.S., particularly for retail. Finding people with specialized trade knowledge is really difficult to find. And then when it comes to our pro customer segment, unfortunately, we've overvalued a college education and undervalued a trade skill education, and so we are faced with a shortage of skilled contractors and trade employees, right? So the cop-out answer is, on some level, when we announced our work with exoskeletons, and we've announced publicly some of the other projects that we should be keeping secret and really working and getting right, behind closed doors. Part of what we're trying to do is also get people excited who are younger about these professions. And that actually, regardless of if we have exoskeletons, we actually need to think about how we cultivate new workforces, in all of our industry. So that was one piece of it. The other piece is, given the reality that our pro customer, for example, the average age of an electrician here in the U.S. is 54, and they're working longer, they have fewer safety nets. How can we provide new tools for them? And so that really did drive some of our initial work. The other point, and we focused almost exclusively on passive systems. We're retail. We're working either our customers, our pro customers run their own businesses, or we run a retail business with margins that we need to protect. We can't necessarily spend the same amount of money on wearable technologies as an automotive manufacturer potentially could. And so we've looked at new ways. And I will say, when we started a few years ago, we didn't see anything on the market that could meet cost, form factor, and that really targeted the back in the way that we see being meaningful to our employees and to our pro customers. And so we spent some time with Virginia Tech, their assistive robotics laboratory, starting to work on some custom designs. And we were really impressed with it. I'll also say the other wild card for us is for our employees when they wear these things. They may actually be encountering live customers. They may encounter you in the stores, right? And so the look and feel of these things have a completely different requirement. They need to not only be comfortable for folks to wear for an 8-hour shift, they need to not be embarrassing, right? So that when you guys come in, you don't feel like you're talking to a weird cybernetic human and you're uncomfortable and you leave. And it needs to feel, I mean, it's funny, we went through all manner of design issues, identifying where the pockets go, because they need to have tools. They need to have access to their smartphone and their scanning devices for stocking. If you don't mind, I actually want to hijack things for a second. I asked you to throw me a curveball, but I want to throw you guys a curveball. Back to the ROI. And this is something I wanted to have as a private conversation with us, but I feel like maybe it's good for everybody in the room. You said sooner or later we're going to have ROI. One of the challenges I'm trying to address as we continue to build a business case for pursuing this line of work further is, because the cost of your average claim or losses due to a worker being unable to work, due to the high ticket for that, you don't have to have many injuries for that to be a problem in a market that exoskeletons can solve. The challenge with that is we might not have as many injuries to address to be able to understand the real impact unless we employ these suits for 5-6 years. How are you guys, and Joe, you're probably, because you're seeing it from a cross-company view, how are you guys starting to put those concrete ROI models together? I mean,
I have a perfect example for you. I was chatting with a workers' comp provider, a multi-billion-dollar company, and their motivation for an exoskeleton is the following. There's an Amazon fulfillment center that is being built in Ohio, and they've got to install those water sprinklers. Well, they have to install 30,000 of them in this warehouse. And water sprinklers are above our heads, so they're doing this all day long. They average 200, 220 sprinklers a day. And I mean, try changing 50 light bulbs in a row. That's going to kill your shoulder. Now you're talking about installing 250 sprinklers. There's a multi-step process. So you're going to get a shoulder injury. And this workers' comp executive was telling us they tear their shoulder, they have to get surgery, they're out of work for 6-7 months, and we are paying 66% of their salary while they're sitting at home. Psychologically, that's an impact on them. They're used, they're hardworking people, and they want to go to work. Sitting at home is psychologically not good, on top of course, the physical impact. And then the project still has to go on. So the guy that replaces the individual may not be as good as the first guy. So you're paying the salary, they're sitting at home, and you've got another guy who's not as productive. So you lose productivity, you lose a lot of money. The premium for the construction company goes up. Everybody loses when you have a shoulder injury. It's very simple math just to not have a shoulder injury and justify it. So when workers' comp companies are pushing exoskeletons and promoting them to their clients, they see the ROI very, very clearly. So that's one way to look at it, is to avoid a single shoulder injury and see how much that impacts.
have you collected enough data to start to prove out, because that's the theoretical model that gets initial buy-in for a pilot. Have any of you guys, too, had these deployed long enough to start seeing?
I got some feedback on that. So yeah, absolutely. I mean, there's the first glance, clear value, test, which really is not, it's not going to take us anywhere. That might get a product into your lab, but if you want to scale it, you're going to need leadership buy-in, and those folks require data, right? So that's where I think we really need to start. So that's why we got an opportunity to deploy globally, and so when we had that funding released, we wrote a proposal, me and Maury Nussbaum from VT, to do a longitudinal study on that rollout. We have an opportunity here now. So we leveraged it, and we just finished up our 12-month data collection, and the way we're doing it is we have a population of users across 9 facilities in North America, and we survey milestone. We hit them with surveys at milestones, and we have double the number of subjects as controls. They're working the same types of work, but without an exoskeleton, we survey them as well. So we can compare discomfort data across milestones. We can look at utilization. We can look at the percent of overhead time each one of them has and start to form some statistics around, are we seeing statistically different changes in a population of people who use them? And so if we compare our data that we just finished collecting at the 12-month milestone with some of our baseline data, we're seeing interaction effects of group by time, which means the EXO users over time are having significantly less discomfort in some joints than the population of users that aren't using them every day for the same reason. Now, we're using simple ANOVAs to compare at means between milestones, but at the after 18 months, we can apply a full longitudinal statistical design to it and account for participants coming in and out of the study and have a much more finite definition of what success looks like for us. So there's very much a goodwill to the operators aspect of it, but there's also very much a need to prove out over time whether we're seeing significant changes in a population of users, and if those, it's only a year and a half, so the chances of someone being injured in that small group is actually fairly low. So it's going to be very difficult to tie it to injury, but we can tie it to biomechanical data collected in labs, which is another portion of the study we'll get into, and as well as qualitative observations from the floor. I just want to say one more thing with respect to the previous presentation. We need to be really careful about, let's measure, say, something like EMG, muscle activation. Let's look at EMG with the device, and then let's take it off and have them do the same thing without a device, and hey, is it helping? We're seeing it takes about 2 weeks for someone who's been doing a task 600 times a day for 3, 4, 5 years to change their kinematics. They're going to try and work the same way they did without an exoskeleton with it. And so you're not going to see changes in their electromyography profile, right? So you really need to do that time history and see, well, how have they adapted, over time to the utilization of the device? Now, do they work differently and move differently with it?
And Josh, I think that, obviously ROI matters, and, executives have to answer to shareholders. But there's a huge component to exoskeletons, which is the wellness of the worker. We have been very fortunate to have deployed our exoskeletons and getting feedback from the end user, right? They go home at night and they're aching. It's normal to them to be aching in the evening if they're trying to play with their kids or do some gardening. Sometimes they can't do that because of the challenges for their jobs. Sitting at a desk is very different than installing those sprinkler heads. I actually came from the medical device background myself, and I worked with surgeons who are aching. And that was the motivation for the invention that was an exoskeleton upper body by Levitate. But I can tell you guys that we have workers that are telling us that they're not aching when they go home. We have people that are having steroid injections in their backs because of the pain they go through with work. And now they don't have to have that anymore. So worker wellness is clearly, to us at least, a major component that we're seeing for companies to make the investment in exoskeletons. So it is ROI at the end, of course, that's very important, but human wellness has been an incredible advantage and something that we did not expect to be to this level, to be honest. So I'd like to very quickly, I know we're almost out of time, I would like to, if I may, ask for 2 minutes from 2 more individuals on standards for exoskeletons, right? When you have earplugs and certain level of decibels, and you rate fall protection harnesses, you rate welding jackets, etc. Those are all considered personal protective equipment, and they have standards. that are governed by OSHA, etc. I know we have a program here in the US, and there are programs in Europe. Can you, Giovanni, please quickly talk about regulation for exoskeletons and your work on that?
Yeah, let me say that as a company, we are adopting the OCRA standard, and we try to base every hour of evaluation on the OCRA ergonomic standard. That was leading us also to some kind of problem because we need to have very experienced people that need to perform this kind of assessment. And there is always also a level of subjective evaluation about it. So inside Innovation Factory, close to Venice, as you were mentioning, we were also launching a project in collaboration with a startup that has the aim to have a full automatic evaluation of ergonomic of the work position. That is done combining sensors and accelerometers worn by the operator and other technology to capture mainly hand movement. We are quite good and satisfied about shoulder and elbow movement. We have still problem with wrist and hands that are composing also a big part in the OCRA evaluation of the position, simply because lip motion capture is not working well with high contrast with white surfaces. And guess what? Home appliances are called white goods. And also because they're using hands to enter inside the appliance. Think about plugging some electrical wire or something like that. So that is, for now, for us, also the technological barrier that we're trying to break in order to have this kind of automatic evaluation about full ergonomic of the position.
Very good. Marty, can you please tell us about your involvement with the Center of Excellence and with ASTM on standards for exoskeletons?
Well, it's a great segue question because our next speaker, Marisol, from my colleague at Toyota, has done a great job developing internal standards at Toyota. They've done a great deployment, so stick around because you're going to hear a great example of how major automotive company has done that internally. Dr. Chris Reed over there is running the human factors and ergonomics section of the F48, ASTM F48, which is an American standardization committee around exoskeletons and exosuits. So there's some great work being done there. Marisol also chairs the Automotive Wearable Exoskeleton Group, also developing standards relevant to automotive. So there's some disparate groups trying to form standards. We're all trying to do the same thing. ASTM has recently put out a call for proposals for a center of excellence. So I can say that that's looking very promising, and they have committed $1.25 million over 5 years to develop a standardization body. There's been a number of proposals, and I've been lucky enough to be an external reviewer for those proposals. So I can say that the future looks really bright in North America for bringing teams together and developing more standards that we can apply and start strategically scaling these tools. Excellent. 12 seconds left.
When technologies like exoskeletons or any other ones are deployed in very large factories that, I think we were at a Mercedes plant that builds 1,400 cars a day. These types of deployments, I'm sorry, I'm switching topics completely, but they are in a union environment. And, I'm sure everybody heard about the negotiations with GM and the challenges going on there. And this is, of course, prevalent also in Europe. Vinzent, can you please tell us how you think the union is a major component of even evaluating an exoskeleton, less deploying an exoskeleton?
Yeah, sure. I was actually pretty surprised about the exoskeleton topic with the union discussion, because usually we get a pretty clear feedback if they like something or not. And for example, if you put on the VR glasses to someone, they instantly like it, and for exoskeletons it's not so clearly the case. So what surprised me that there were two fractions. The one was saying, okay, it's a great tool for employees, they will benefit from these health effects, and then there were others who said, okay, no, it's going to turn them into robots. This is something we really have to clearly watch. And so this discussion was not the people did not make this discussion to an end. And then there were also like people who said, before I was just simply pushing boxes from A to B. Now I'm going to operate this complex machinery, so doesn't that justify some kind of raise of my salary or something like that? So these are the kind of discussions that you have to do, that you have to be prepared for, and that will not have the one single answer to that.
It is definitely a complex environment. So I really want to thank you, gentlemen, for this. I think that I honestly and sincerely feel that the exoskeletons will, now they're new and innovative, but they're going to be standard personal protective equipment. But I really enjoyed learning from this panel, and I really believe that Enterprise, the Brain Exchange has done a fantastic job. We are thrilled to have been at this conference, and I would like to end with a note that it is inevitable that Lowe's will be selling exoskeletons to consumers. So thank you all very much.